I'm Ethan Seth.
I'm Brandon Lusk.
I'm Owen Gage.
And I'm Michael Lively.
Together, we are Tangled Spaghetti, and we're here to talk about our project, the Stat Cycle. When we started thinking of the Stat Cycle, we had to define some measures of success to define what our project would actually end up being. One of the main ones that I worked on was our speed-to-spokes technology. This is technology where we take GPS data and we take specifically the speed data from our main board and send it down to our daughter boards via radio signal. On the daughter boards, the LED lights change to signal to pedestrians that we are either speeding up or slowing down.
Another measure of success that our group accomplished this semester was writing to the SD card. We were able to put a file system on the SD card and read and write files. Additionally, I worked on the 7-segment display to be able to indicate what mode our main board was in, as well as the current speed that the rider is going at.
Another one of our measures of success was getting actual GPS data, and I worked on that module. I was able to get position, velocity, and time data off of a module and then send it to the SD card, as well as send it to the 7-segment display to be displayed, obviously, and also send it to the radio.
Yeah, and our final measure of success was a companion iPhone app that would be able to pair to the Stat Cycle, export your GPX files off of the Stat Cycle, and then finally upload them to Strava via their native API. And this was all accomplished through a phone app built in React Native.
And then the counterpart to that phone app was the Bluetooth integration that I did on the main board to be able to expose the inner workings of the file system to Michael's app. The one measure of success that we did not meet this semester, however, was the ability to display when we were braking to a third daughter board that was supposed to be tied to our seat post. And the reason that we did not complete this measure of success was actually an issue of our budget. We were already like $100 over budget, and we did not want to spend the money to buy components to build what was essentially an identical third daughter board to be able to display the brake light.
With that, we'll go into showing some of the inner workings of our app via some demos.
Here we are. We just started our ride. We have a fix acquired, which is awesome, and is recording data out to the SD card as we speak. Unfortunately, we're inside on a cloudy, rainy day, so our accuracy isn't the greatest, but in fact, it's very poor. Now we have been sitting here for some time now, and as you can see, our velocity is a little inconsistent again because we're inside, but that doesn't much matter. We're going to go ahead and stop our ride, like so. We are now back in the default state. We will now enter Bluetooth pairing mode.
And we can bring in the application.
Hold on. Yep.
So then once the board is confirmed to be in Bluetooth pairing mode, we can scan and connect to the Stat Cycle. It will load for a second, and then once you see a pop-up saying pairing successful, you'll be able to proceed further with the app. Right now what it's doing is it's populating this menu you see at the bottom. So now if we press OK and select data file, we'll see all of the rides that we have stored on our board.
It is 12:40 on December 14th.
So if we scroll all the way down, we will see on December 14th, 12:39 was when we started this ride. So we can click here and select it. We'll get a prompt saying file selected, and then we can export the GPX file. And this will take a second, and we'll wait till we get a file exported command. Now we have file exported. And now that we have the file exported, it's stored locally on your device, so you can post the ride to Strava. So we'll click here, we'll call it
Hallway Test 2.
Hallway Test 2. We click Save. Now it's going to load a second. It's going to ask us to select the GPX file, so we'll navigate to our folder, and we'll see at 12:39 that file was successfully exported in the GPX format. Select it, and then now it'll go ahead and upload to the API, so we'll authorize our account. So we'll authorize it to use all of our data. And then now we already see all done. So we'll click here, it'll redirect us to the Strava app, and now we see Hallway Test 2. As you can see, it's not the most accurate ride because we are inside on a cloudy day, but there is our ride.
Now that you understand the full functionality of the Stat Cycle, we'd like to highlight another of its crucial features. Here we're looking at our speed-to-spokes technology, where we have a daughter board in the spokes of our wheel that changes color as we increase speed along our bike ride. Here we see it going from red to green and all the way up to blue. Another thing we can demonstrate better outside is our GPS capability, which is actually quite accurate when we're in the appropriate setting. Here we see a ride where we spelled out ECE in homage to the electrical and computer engineering department.
And now we're going to move on to talk about some bugs and challenges that we wish we could have addressed had we had a bit more time in this semester. To start with my mobile app, I wish I could have developed a bit more of a better UX flow in the design, give the user a bit more feedback as they're interacting with different parts of the app, rather than just relying on thinking they pressed the button or interacted with a certain UX feature.
We had a number of issues integrating all of the software pieces together, especially with the GPS, and there's still some bugs with concurrent tasks that need to be fixed if we had more time.
For me, when I was designing the hardware of the main board, I really wish we would have put a UART on the main board for debugging. That made debugging quite challenging. And additionally, with the Bluetooth file server that I built, I wish I would have had a little bit more time to dig deeper into the protocol, because I think the way that the system works right now, it is functional, but there probably is a better way using all the standards of Bluetooth Low Energy to send files.
For me, I would have liked to add in a few things about the daughter boards, namely on the software side. I would have liked to add more modes. Speed to spokes technology is really a key factor of the stat cycle, and without having a lot of modes to change between, the user's somewhat limited in how they can display their speed to pedestrians. So in the future, if I had more time, I would have liked to do that.